Hey guys, this is Jordan with the practice set, and today we're going to do some calculus U-substitution integration problems. So let's go through this. The question is telling us to take the integral of 2x e to the x squared dx. So yeah, based off of the rules that we know, as we see right here, we don't really know how to integrate this. This is actually pretty complicated. So the best way to integrate this is we substitute out one or more of the terms involved. So the question now becomes, which term are we going to substitute in for u? And it's going to be this term x squared. And the way that we determine that is we look at the terms and say, how are any of them related, if any of them are related? And what we see here is that x squared, when differentiated, is equal to 2x. And the reason that that becomes important is because they'll cancel out later. So now that we've determined what our term that we're going to substitute in for u is, this x squared, what we're going to do is, set it equal to u. We set u equal to x squared. And now we're only focused on this equation here. We'll get back to this, but we throw this to the side and focus completely on this right here. So we differentiate both sides to give us du over dx, which is another way of saying the derivative of u with respect to x is equal to 2x. As we saw, remember, that's why we did that right there. The derivative of x squared is 2x. So now what we're going to do is we're going to try to get the dx on to the right side. And the way we do that is we multiply both sides by dx. The dx is in the numerator right here, so it'll cancel out. So we get du is equal to 2x dx. Now what we do is we see here that du is equal to 2x dx, and 2x dx is in the problem. 2x times dx. We can rearrange it either way, so we can just plug in u for that. So now, as you see right here, 2x e to the x squared times dx is the same as e to the x squared times 2x dx. It's exactly the same. So we plug in du for 2x dx right there. And because we substituted u for x squared, the integral is e to the u times du. Now this is something that we know how to differentiate, because we know how to differentiate exponents. So the integral of this exponent e to the u is e to the u plus c. We always must remember that when we're using indefinite integrals, and we're getting indefinite because we don't have any terms above and below the integral. But that's unimportant. So the integral of e to the u times du is e to the u plus c. So now we have what our final answer is, except we weren't given u in the original problem. So what we have to do is we have to resubstitute back in whatever the term was for u, which happened to be x squared. Set u equal to x squared. So that gives us e to the x squared plus c. And this is our final answer. And an easy way for us to check if this is the answer, because it was an integral, is we merely take the derivative. The derivative of e to the x squared is 2x times e to the x squared right there. And that was our original. So that's our final answer. So I hope you guys learned a lot from this problem. We have a bunch more on our website, the practice set. It's a upper level STEM practice problem database where we take courses just like these, break them down into the problems that you need to know, and solve them out step by step and explain every step of the way. We really hope that you check us out, because we have all types of problems in any type of course. So we really hope that you'll come and find out more about us. We have a link in the description of this video, and we hope to see you there. Bye-bye.